Hi, my name is Mark Thoren. I'm a staff scientist for mixed signal products at Linear Technology. I'm going to talk about the LTC 2945 Wide Range Power Monitor. With more and more emphasis being placed on efficiency and reliability, it is necessary to monitor power use, often at multiple points and at different voltages within a system. The LTC 2945 helps solve some of the more challenging measurements. On the surface, you can think of the LTC 2945 as a 0.75% accurate analog to digital converter with a 0 to 80 volt input and a current sense input whose common mode extends from ground to 80 volts. An auxiliary 2.048 volt input is also available. The ADC continuously scans the various inputs, and current and voltage at either VDD or Sense Plus are multiplied to calculate power. The latest conversion data is always available for reading. Minimum and maximum values for each measurement are tracked, and upper and lower limits may be set such that an alert is triggered if exceeded. A 48-volt bus can be particularly challenging to measure. 48 volts usually means more like 36 to 72 volts. Also, it is often not desirable or even prohibited to insert a sense resistor in the return path of a supply, so the current sense will be at the high side in a positive 48-volt system and at the low side in a negative 48-volt system. The LTC 2945's rail-to-rail current sense handles both of these, and power is derived directly from the supply being measured. Other monitoring applications may need to measure a supply that may or may not be operational, that is, a supply that can go all the way to zero. A secondary high-voltage supply can be connected directly to VDD, and the voltage measurement can be set to measure the Sense Plus pin. Another option is to connect a low-voltage supply directly to the INT-VCC pin. For example, the same supply as the microcontroller that is reading the LTC 2945. Even with a low-voltage supply, the current sense and voltage measurement still extend to 80 volts. What if your supply exceeds the 80-volt operating voltage of the LTC 2945, as might occur in an offline regulator application? INT-VCC can also function as a 6.2-volt shunt regulator. This allows the part to be powered from any voltage through a resistor or transistor current source. Just make sure between 5 and 15 milliamps are always flowing and that the resistor's voltage and power ratings are not exceeded. And finally, the microcontroller that needs to talk to the LTC 2945 may have to be galvanically isolated from the supply being measured. I2C is the bus of choice for board-level monitoring, but its bidirectional, open collector operation makes isolation inconvenient. On the I2C bus, the clock line only needs to be bidirectional if clock stretching is employed. The LTC 2945 does not stretch the clock, so it can be isolated with a single device. SDA is normally a single signal, but the LTC 2945 brings out a separate SDA out and SDA in pin, greatly simplifying isolation. Refer to the datasheet for various options. Enough pictures, let's see some hardware. Here I have the LTC 2945 demonstration circuit measuring a 48-volt supply. The software is essentially a map of the internal registers, data, minimum and maximum recorded levels, and fault limits. I've got a voltage limit set to 60 volts and a current limit set to 0.75 amps. Let's crank it up and check that it works. Sure enough, the alert pin pulls low as shown by this LED. Next, we'll clear the fault and halt communications with the LTC 2945. Even though we're not talking to the part, it is still performing all of its monitoring functions. To demonstrate, I've set the current limit at 0.75 amps. Adding an additional load trips the alert. This means that you don't have to tie up the I2C bus polling the LTC 2945. It will tell you when something bad happens, and then you can read out the min, max, and fault registers to see exactly what happened. The LTC 2945 is loaded with features to make your high-voltage power monitoring tasks easier. The 0.75% measurement accuracy enables accurate monitoring of system power and diagnostics. Multiple options for powering the part adapt to the supplies that are available, and a split I2C bus make isolation a breeze. Please visit linear.com for more information. Thank you for watching.